3IATLAS is giving scientists headaches, and it might not even be natural. 3IATLAS, a mysterious visitor from our solar system, has been keeping astronomers on their toes. Its trajectory, composition, and now its slowing speed are raising questions that challenge everything we thought we knew about comets. In this video, we break down what makes this interstellar object so strange and why some experts are considering radical possibilities. Follow along as we uncover the strange behavior of 3IATLAS. Subscribe and turn on notifications to stay updated on this cosmic mystery. The discovery that changed everything. It's July 2025, and astronomers in Chile are scanning the night sky with the ATLAS telescope, doing what they do every single night. Nothing unusual, just routine observations. Then suddenly, their screens light up with something that makes them do a double take. They've spotted an object moving through space, but this isn't just any space rock passing by. The team quickly realizes they're looking at something extraordinary. This object isn't bound by our sun's gravity. It's traveling through our solar system from somewhere else entirely, somewhere between the stars. They name it 3IATLAS, the third confirmed interstellar object ever detected by humanity. The first was the mysterious Oumuamua back in 2017, followed by Comet Borisov in 2019. But here's where things get fascinating. From the very first observations, 3IATLAS starts showing characteristics that don't quite add up. It's moving on a path that brings it surprisingly close to several planets in our solar system. The astronomers plot its trajectory and realize this visitor is heading toward the inner regions, scheduled to make its closest approach to the Sun on October 30, 2025. What makes this discovery even more thrilling is the timing. We're catching this object relatively early in its journey through our cosmic neighborhood. That means telescopes around the world have months to study it, to gather data, to try and understand what exactly we're dealing with. Observatories from every continent start pointing their instruments at this mysterious traveler. The initial excitement in the scientific community is palpable. Every interstellar object we've detected has taught us something new about the universe, our solar system. But nobody knows yet that 3IATLAS is about to become the most puzzling visitor we've ever encountered. The real mysteries are just beginning to unfold. The expected behavior of comets. To understand why 3IATLAS is causing such a stir, we need to talk about how normal comets behave. When a typical comet approaches the Sun, it follows a predictable script that astronomers have observed thousands of times. It's like a cosmic dance choreographed by the laws of physics. As a comet gets closer to the Sun, the ice on its surface starts heating up. This frozen material, made up of water, carbon dioxide, and other volatile compounds, begins to vaporize. This process is called outgassing, and it's what gives comets their spectacular tails. The evaporating material shoots off the surface, creating those beautiful streams of gas and dust that can stretch for millions of kilometers. Here's the crucial part. When material blasts off a comet's surface, it doesn't just disappear. According to Newton's third law, every action has an equal and opposite reaction. So when gas and dust shoot away from the comet, they push the comet itself in the opposite direction. This creates what scientists call non-gravitational acceleration. Think of it like a rocket engine, but instead of burning fuel, the comet is losing ice. This rocket effect causes the comet to deviate slightly from the path that gravity alone would dictate. Astronomers can measure these deviations with incredible precision, and they use them to calculate important properties of the comet, like how much mass it's losing and how big it actually is. For decades, this understanding has worked perfectly. Scientists can predict a comet's path, account for the non-gravitational acceleration from outgassing, and their calculations match observations beautifully. It's one of those areas of astronomy where the science feels settled, where the equations work exactly as they should. Until 3IATLAS came along and decided to rewrite the playbook. The anomaly nobody saw coming. Now we get to the part that has everyone scratching their heads. When astronomers started tracking 3IATLAS with extreme precision, using observations from 227 different observatories around the world, they noticed something absolutely bizarre. Or more accurately, they noticed the absence of something they absolutely expected to see. Between May and September 2025, Scientists gathered 4,022 individual measurements of 3I-ATLAS's position. They were looking for those telltale signs of non-gravitational acceleration, the little pushes and nudges that outgassing should create. They had the equipment. They had the time. They had the perfect opportunity to measure these effects. But the measurements showed something shocking. The non-gravitational acceleration was incredibly small. In fact, it was so tiny that scientists could only establish an upper limit of 15 meters per day squared. To put that in perspective, this is far less than what they should be seeing from an object that's actively outgassing. Here's where it gets really weird. The James Webb Space Telescope observed 3I-ATLAS in August 2025 and confirmed that it is releasing material. The comet was shedding about 150 kilograms of material every single second, with gases shooting away at speeds of 440 meters per second. That's a serious outgassing activity. By all rights, this should be pushing the comet around noticeably. So we have a paradox on our hands. 3I-ATLAS is acting like a comet, showing all the visual signs of outgassing activity, creating a visible coma and even developing tails. But it's not moving like a comet should move when it's losing all that material. It's as if the rocket effect simply isn't there, or it's being overpowered by something else entirely. This isn't just unusual. According to everything we know about comet physics, it shouldn't be possible. The mass calculation that shocked scientists. When faced with this apparent impossibility, a team of scientists led by researchers including the well-known Harvard astronomer Avi Loeb decided to work backward from the data. If 3I-ATLAS isn't being pushed around by its own outgassing, there has to be a reason. And the most straightforward explanation is absolutely mind-blowing. The math is actually pretty simple, even if the implications aren't. When material shoots off a comet's surface, it exerts a force. That force creates acceleration, which depends on the comet's mass. The bigger the mass, the smaller the acceleration for the same amount of outgassing. It's basic physics, but when you plug in the numbers for 3I-ATLAS, something incredible emerges. Given the observed outgassing rate from Webb telescope data and the mysteriously low non-gravitational acceleration, the scientists calculated that 3I-ATLAS must have a minimum mass of 33 billion tons. Yes, you heard that right. 33 billion tons. That's an absolutely staggering number for a comet. To put this in perspective, the other interstellar comet we've studied, 2I Borisov, was estimated to be thousands to millions of times less massive. Even accounting for uncertainties in the measurements, 3I-ATLAS appears to be in a completely different league. If this mass estimate holds up, we're talking about an object that's 3 to 5 orders of magnitude more massive than the other interstellar visitors we've detected. At solid density, this mass translates to a nucleus diameter of at least 5 kilometers. That's huge for an interstellar object. The Hubble Space Telescope's observations suggested a size range between 0.44 and 5.6 kilometers, so this calculation puts 3I-ATLAS right at the upper end of that estimate. We're potentially looking at one of the largest interstellar objects ever detected crossing through our solar system. The statistical nightmare. Here's where the story takes an even more troubling turn for astronomers trying to explain 3I-ATLAS naturally. The mass calculation doesn't just raise eyebrows, it creates a serious problem with the statistics of interstellar objects. Think about it this way: rocky material gets ejected from planetary systems all the time throughout the galaxy. Collisions, gravitational interactions, all sorts of cosmic violence sends debris flying into interstellar space. Over billions of years, this creates a vast reservoir of wandering objects between the stars. But here's the catch: there's only so much rocky material to go around. The heavier elements needed to make these objects aren't infinitely abundant in the universe. So when scientists calculate how many interstellar objects of different sizes should be floating around, they get a pyramid-shaped distribution. Lots of small stuff, fewer medium-sized pieces, and very rare large objects. Based on these calculations, if 3I-ATLAS really is as massive as the data suggests, we should have detected roughly 100,000 smaller interstellar objects before finding something this big. But we haven't. We've only found 2 other confirmed interstellar visitors before 3I-ATLAS, Oumuamua and Borisov. The odds don't add up. It's like winning the lottery 3 times in a row. Sure, it's technically possible, But it strains credibility. Either we've been extraordinarily lucky, or something about our understanding is fundamentally wrong. Maybe the interstellar mass reservoir is different than we think. Maybe detection methods favor certain types of objects. Or maybe, just maybe, 3IATLAS isn't a natural object at all. This statistical anomaly is what's keeping scientists up at night. It's not just one weird measurement, it's a web of observations that don't fit together neatly into the natural comet hypothesis. The trajectory that raises eyebrows. 3IATLAS's trajectory through the solar system is drawing attention because it is unusually aligned with the ecliptic plane, the flat disk where most planets orbit the Sun. While natural interstellar objects can approach from virtually any angle, the odds of one coincidentally matching the ecliptic so closely are roughly 1 in 500. This alignment alone is curious, but it becomes even more intriguing considering the comet's path brings it relatively close to several major planets, including a flyby of Mars in October 2025 and an upcoming approach near Jupiter in March 2026. Some researchers have noted that such a trajectory resembles an efficient observational path, almost as if designed to study multiple planets up close. While coincidences do occur in space, the combination of this unusual orbital alignment with 3IATLAS's other anomalies, its mass, composition, polarization, and activity, adds another layer of mystery. Each detail reinforces that this interstellar visitor is far from ordinary, leaving scientists to question whether we are seeing a simple natural object or something far more complex. The color changes nobody expected. During the summer of 2025, astronomers tracking 3IATLAS observed a notable change in the comet's coma, which became progressively redder through July. While color shifts in comets can occur naturally as different materials vaporize when heated by the sun, the reddening of 3IATLAS suggested active changes in the surface composition or the materials being released, reflecting real-time evolution in its activity. Scientists documented this trend, highlighting that the comet's behavior was more dynamic than typical solar system comets. In September 2025, a green glow also appeared around 3IATLAS, likely caused by carbon molecules fluorescing in sunlight. What made this unusual is that earlier spectroscopic studies hadn't detected significant carbon, implying that either initial observations missed something or that new materials were being released as the comet approached the Sun. These color variations indicate a layered, evolving surface and emphasize the complexity and unpredictability of 3IATLAS, adding yet another layer to its growing list of anomalies.